Hi everyone, and welcome to this demo about Spark Declarative Pipelines. It will be a kind of introduction to this shiny new feature in Apache Spark 3.1, and we are going to see some basic stuff that will, I hope, help you start with writing declarative pipelines. To put it short, we have here different scenarios. The first one will be correct executions. We are going to discover here various declarative ways for tables, for flows, and for temporary views. Next, we are going to see some kind of tricky parts where you, for example, have multiple downstream flows and one common parent. So we are going to see what happens here. And finally, we are going to also discover errors. So what can go wrong and what happens with the SDP pipelines. So let's get started. And to start, I need to begin with a Docker Compose. Docker Compose that has a Spark 4.1 with a Delta Lake extension and some additional dependencies, additional jars that I need to have because I'm starting Spark Connect, and without them I won't be able to use like Delta writers or Kafka writers in my demos. And regarding Kafka, I also have Apache Kafka that starts right here and creates in another container two other topics that I'm going to rely on in the demo. The first one is called numbers and the second one is called write data. And the first demo, let me just check, is about materialized views. So the materialized views are kind of construct that you can use to write batch processing in Spark Declarative Pipelines. Here I have one temporary view, which is an upstream view, and one downstream view that with the table API will read this temporary view and combine it with the data that is just created here in memory. So I'm choosing this very simplistic approach on purpose because there's nothing better to understand new concepts than very easy to set up demos and code. And aside from that, I have another materialized view that this time will read text files. These text files are mounted as this directory to my Docker volume, like here. So let me get started, and to get started, I need to start Docker Compose, of course, in the first place, which is like here. Okay, as you can see, we created correctly two topics, and Apache Spark Connect also started at the usual port. So let's get started with this very first pipeline. And if I run it, you should see a few interesting things like the different flows that are passing from the queued to the starting state, to the running state, and to finally to completed state. I'm not going to explain them in this video because I have 3 blog posts dedicated to Spark Declarative Pipelines, and I'm just here in this video to show you how it works, how it runs, in a more interactive way than just in text explanation. So typically here we should have created 2 different tables that are the materialized view text letters and text letters in memory numbers, and these 2 tables can be pretty easily run and read with this function. So I have my first table and my second table just here. And before we move on, we can stop and analyze a little bit the workflow. So the Spark Pipelines is a CLI file where Apache Spark Declarative Pipelines exposes different methods, like for example run, when you can of course find all the required elements to run a SDP workflow. So the specification path, configuration for the refreshes, and also configuration for the dry run. And the most crucial part here is the spec. The spec is a YAML file where you define the name of your workflow, the storage where you will store the checkpoint data, and the libraries that are going to be included in the execution. So Spark will generally include this single, it's not a good file in fact, but let me just show you the good one. The good one is just here, sorry. Okay, so but the explanation is the same. So Spark will generally include only this file in the execution. And of course, we also have a possibility to configure Apache Spark Connect. And in my case, I'm defining the remote address for Spark Connect, the catalog implementation, and also a smaller number of shuffle partitions because I don't want to deal with a lot of shuffle partitions, because usually, I'm digressing a bit, but if you run unit tests, you run Spark code locally, more shuffle partitions mean more overhead and potentially a longer execution time. So that's the spec. And you already saw the API, the high-level API. All Spark Declarative Pipelines so the Spark Declarative Pipelines relies on decorators that are exposed here that will generally wrap your function and pass it to Spark Connect server via a registration method that is present somewhere here, because I was just investigating it a few days ago. So you have here a registry, which is Spark Connect construct, and register definitions where you can find Spark registering all the decorated things from your spec. So let me just find maybe something here. I remember it was something with modules. Yeah, that's here. And we have our register definitions. And of course, we are trying to find everything to register here. So in this demo, I'm focusing on a PySpark API, so on Python. But as you can see here, there is also a support for SQL. If you prefer a SQL declarations, which is probably even more close to the whole declarative paradigm, you can do it. That was the first demo. The second demo is about a kind of a little bit different declaration part. So which is this, yeah, this is the table declaration with a Python function. So my biggest worry for SDPs were testability. So how do you test the pipelines, right? Because these wrappers are great, but if you prepare a production code, you will usually need to test your things to provide some kind of continuity and easy maintenance without having to deploy, of course, all this stuff on your Databricks or on your EMR, Dataproc, on your Spark execution environment. So generally, as you can see here, we have a possibility to still use Apache Python native functions that will accept some parameters, which in my case is a data frame coming from the SDP workflow, and later you can test it in isolation. And in this demo, I'm using another SDP abstraction, which is the streaming table. So the streaming table is an append-only data sink where Spark will simply continuously add new data coming from the data frame you expose here. In my case, again, I want to keep it simple. I'm using the rate per micro batch data source, and I will continuously write few rows to the table called rate data with processing time. And by the way, I also mentioned it in the blog posts, but I want to highlight it just here. Even though we are, you will see it in a minute, but even though we have here a streaming data source, it doesn't mean that Apache Spark will run it continuously, right? You don't see any trigger here. One of the premises of SDPs for me is the abstraction of many concepts, like you saw it with checkpoint location, like you don't You see it currently with not having to deal with await termination or any this kind of structure streaming API stuff. And generally, triggers are one of these hidden abstractions. And under the hood, Spark will run all streaming queries with available now triggers. So that's why you will see that this pipeline will start and stop just after. And to see it in action, let me run it. So everything is queued, started, and completed. And now when I query the table, you can see that I have only a few rows in there, which are the values with the decorated processing time. So these were the streaming tables, and you can also define the streaming table with a different approach, which is a prior declaration with create streaming table helper function and append flow decorator, which can be pretty convenient if you have two different data sources. So for example, so typically you are doing the fan in approach when two upstream nodes combine into a single downstream one. And in my case, to distinguish these two, I set a different start timestamp for the second data source, and let me just run it to see what happens and to see it in action. So you can see that both are queued and starting and running. And now when I query them, I should see two different timestamps inside. And finally, the last one in this correct execution is the Kafka sync. So the Kafka sync is not a table, but again, with a helper function called create sync, you can declare your arbitrary data sync for Spark Declarative Pipelines. So in my case, I'm running a stream on top of files, and I'll be writing them to the numbers Kafka topic. Let me just run it. And now I will run the consumer, Kafka consumer, to see the content. And you can see that I have my 3 rows that are present in the text file. Okay, that's the first easy peasy part. And there is also something much more challenging, which is like when you have many upstream dependencies. When you have one upstream dependency for two downstream pipelines workflows, which is typically the use case of the fan out pattern. So here, when you try to run the first one, which is this function, you will see that we cannot really do some kind of tricky, hacky part where they find to decorate the function with two different append flows. Yes, that's typically coming from Python, and probably the PySpark limitation. So another configuration could be this one. When we have a materialized view, when you have two materialized views, so the batch pipelines that both read this temporary construct, temporary view. And here my point is to see whether this specific part will execute once or twice. And when I run it, you can see that the function will be sleeping for 20 seconds, and that I'm spoiling you a bit. It will be the single time you are going to see the sleeping log in this demo. You can see that there's nothing else that happens, and I will just check the data, but generally the answer is because this temporary view is a full in-memory view, Spark will not recompute it. It will just use the underlying data frame. And if we check now something different, which is an Apache Kafka topic to change, here things will be a little bit different, right? Again, I have the temporary view there that will subscribe to a rate data topic that I created previously. And downstream, I will have two rate sinks tables, streaming tables, that are going to read this temporary streaming view. So I'm just giving the sleeping to show you the log, but I'm not sleeping it to make it a little bit faster. And besides this, I also have a Kafka producer that will continuously, like almost continuously, producing some data to the rate data topic. So let me first start the producer just to have some data inside the topic, and later I will start the SDP pipeline. So let's count until 5. 1, 2, 3, 4, 5, and start the workflow. You see that there are full completion. And now when I check the content of the delta tables, especially the last rows, you will see that the first thing got less value than the second one. So the reason for that is simple. If you remember Apache Spark structure streaming, and let me maybe find this on the blog, we'll create 2 separate queries for 2 separate things. Yeah, this is this blog post. And the point is that when you run these kind of things in Spark structure streaming, under the hood it creates 2 separate jobs that don't share the same input. Right? There is no possibility to do a persist or unpersist on the streaming data frame. And for that reason, these 2 streaming queries have different input and consequently different output. And for the exact same reason, this Spark declarative pipelines, where I define a common temporary input view, produces 2 different results here. So here typically for the first table I took 10 records less than for the second one, right? And what happens when we have delta lake table? So here the logic is very similar. I have 2 downstream consumers and 1 temporary view in the input. And I also have a producer that will continuously write some rows to this table. And here too, you will see something interesting. So I will start first my producer. I will count now 1, 2, 3, 4, and 5. I will start Spark declarative pipelines and wait for completion. So as you can see, the data producer is continuously running. And now I will just change the location here maybe of this table, of these tables, and run the workflow. Okay. Yes. So now let me start this pipeline and see what happens inside. Okay. Will it work this time? Yes, we have our streams that are queued, starting and running. There's probably too much data to complete it earlier, so we have to wait a little bit more than previously. And yeah, both are completed. And if I check now the content, you will see that there is kind of slight difference between these 2 pipelines, exactly like for Apache Kafka. So we have here 3,479 and 3,439. So there are 40 rows, the difference between these 2 parts. And generally, the reason is very similar to the previous one, like because we are running 2 different streaming queries, we obviously have 2 different inputs and 2 different configurations. So the single time where the data will be the same is when your table is part of the Spark declarative pipeline workflow, and it's only and consequently it can only be changed within the same pipeline. So in that case, Spark will use the snapshot and will isolate it and use a common data source for 2 downstream branches. And when it comes to the errors, so Spark will retry a few things. will retry your workflow a few times. So like here, you can see that we are trying to do some kind of inconsistent schema operation by casting string to big int. We can see that we have one retry, second, 2, 3 retries, and in the end it fails. So it's very interesting because it can help you deal with transient errors, that the errors that are temporary and can be automatically resolved, like network connection failure for a short period of time. But of course, it will not help you when you have some error in your data processing logic, like it's my case. So I think that we can stop here. I showed you a few things. Remember, we started with seeing the API, with discovering the API, the decorators, different ways of defining the strings, the sinks, and second we saw how to a little bit more complex Spark Declarative Pipeline setup with one upstream producer and two downstream consumers. And you saw that it behaves exactly the same like with Spark Structure Streaming when you write two streaming queries inside the same job. So typically there's no guarantee that your input will be the same. And finally, we also discovered the errors and retries that can be very useful to deal with transient issues. And that's all for me today. If you want to discover more on Spark Declarative Pipelines, I invite you to the link which is to the blog post, which is linked in the description of this video, and it will be the first blog post of the series of 3 articles dedicated to this new Apache Spark 4.1 feature. It was Bartosz Konieczny from waitingforcode.com, and thanks for watching.